Okay, here's a walkthrough on how to solve these restriction mapping problems. This is exercise 1 from Blackboard. And remember that this is circular DNA, and how we're going to solve this. What's the first thing you need to know? You need to know how big is the plasmid. How will you determine that? By looking at the fragments that result from the restriction digests. So remember that when we cut this plasmid up with restriction enzymes, no matter how many times it's cut into pieces, all of the pieces have to add up to the same, and that's the size of the circle, or the size of the circular DNA, I should say, more accurately. When we look at, for example, the BAMH1 digest, or the ECOR1 digest, or even the PST1 digest, all of the DNA, the lengths of these pieces have to be the same, or the sum of the pieces have to be the same. So with BAMH1, we have one fragment, and it's 3903 in size. So I know that my plasmid is 3,903 base pairs in length. And notice that that's the same size that we see with ECOR1, and if we add up all the pieces that result after cutting with PST1, 2403 and 1500, that would also add up to 3903. So there's a conservation of the DNA. It's just being cut. It's not being digested or degraded or erased somehow. So the size of the DNA, that's the first step. What's the next step? It's how many times do each of these enzymes cut? So we're cutting with 3 enzymes, BAM, ECOR1, and PST1. BAMH1 cuts once, because we have only one piece. And so I can just arbitrarily decide to place the BAMH1 site somewhere along this circle. ECOR1 cuts only once. And so I could create a new map showing how many times ECOR1 cuts, and it's just once. I don't know yet the distance between ECOR1 and BAMH1. I'm going to figure that out with the double digests over here. But don't worry about it for now. Next thing I'm going to do is how many times does PST1 cut? I'll use a new color. PST1 has to cut, a thin fragment here, twice. How do I know it cuts twice? Because I have 2 pieces that result after you digest with PST1. So think about a rubber band, like a circle. If you cut a circle once, you're going to have 1 piece. Cut a circle twice, you'll end up with 2 pieces. So that tells me that PST1, I'm just going to use the letter P here, has to cut twice. And I even know how far apart they are based on the sizes of the pieces that I result. So there's a short piece and a long piece. So PST1 has to cut to result in a short piece, 1500, and a long piece, 2403. Now that's marks right there, if you get that much right. Okay, so if you got this far, you get marks, because you can show me the restriction map for each of the enzymes individually. Now that's not your whole job, but it's a good start. What's next? We have to figure out how far apart each of these enzymes are from each other. So, for example, I know that ECOR1 cuts once, and that BAMH1 cuts once, but how far apart is BAM from ECO? We need to cut them both at the same time. So we have to look for the BAM-ECO double digest, which is right here. Oh, not conveniently for me, that's the first one that shows up. So BAM and ECO, when you cut with both of these enzymes, we end up with 2 pieces that are almost the same length. They're very, very similar. And if you can just read the bottom one, I think says 1918, which makes sense because 3903 is almost 4,000, so we should have 2 fragments around 2,000. Without even doing math, I can figure that out. I think you can too. So I know that the ECOR1 site, and I used red for ECO, so I'll use red again, has to be almost on the opposite side of BAM. Because I know that one fragment, the shorter one, which is from here to here on my map, has to be 1918. And if you subtract 1918 from 3903, I think you'll find that the number is 1985, and that must be the length of the other fragment, 1985. So I've mapped BAM to ECO. That's part of my map. And I also have to figure out where are the PST1 sites relative to these two. So if I look at the double digest of PST1 and one of these, well, let's start with BAM because it's the next one in the row, we see that 3 fragments result. So we have these 2 fragments that result when we cut with PST1, the 1500 and the 2403, and then we cut one more time with BAM, and so BAM has to be cutting somewhere along here. Where does it cut? Inside of here or inside of the longer piece? Well, we can see that this longer piece is no longer here in the double digest, so it must be cutting on the 2403 region, and it cuts that fragment such that there's a 1500 or a 1430 base pair fragment and a 973 base pair fragment. So that tells me that somewhere along the PST digest, that the BAM site has to be cutting this fragment, 2403, into a fragment which is 973 and a fragment which is 1430. So on my map, I could arbitrarily place PST such that it's on something like this. PST, PST, and one of these pieces has to be 973 base pairs, and this piece has to be 1430 base pairs. And of course, we still have this 1500 on the opposite side. Now that suggests that the ECO site is cutting inside of this 1500 base pair fragment. And is that the case? Well, let's look at when we digest with PST1 and EcoR1, and that's shown here. Where does EcoR1 cut? Well, with PST1 alone, we had 2 pieces, 1500 and 2403. When we add EcoR1 to that digest, we see that this 2403 fragment is not cut. It's in fact the 1500 base pair fragment, which is what we predicted from our map. So the 1500 base pair fragment is cut into 1/3, and the remainder 488 or 1012. So that suggests that this little piece between EcoR1 and PST1 is 488 base pairs. So let's have a look. Oops. If this map is right, then when I do the triple digest, when I digest with all 3, I would predict just from my map that I would have a 1430 base pair fragment, a 488 base pair fragment, oh, and I forgot to write this other one, 1012, a 1012 base pair fragment, and then from PST to BAM, each one on 973. So 973, 1012, 488, 1430. And is that what we get? 1430, 1012, 973, and 48. So I think my map's correct. And just to make it pretty, get this out of the way, and I'll draw it again. All pretty nice. So our BAM H1 is here. We have a fairly large fragment of 1430, and then we have our first PST site, and then there's an ECO site and a fragment of 488, and then another PST site, 1012, and then between BAM and PST we have 973. And so there's our map. Now notice that your map might be identical to this, only just a mirror image. So if you flip this around, your fragments here might be on the opposite sides, but as long as you have the same order, it's the same map. It's just that it's the mirror image of the other, and without more information there's no way to determine between the two. So that concludes this example on how to solve this map. this restriction mapping problem, and I hope that helps you out, and see you on Tuesday.